Okay, for 6.2, I already started it, and then I slaughtered my discussion to start out. I want to start by mentioning that 6.2 is brand new for this edition. My old videos, if you're watching my old videos where I'm working them out on the whiteboard, what you will see is when I talk, I'm going to be one section off from here on out. 6.1 is the same. After that, when I say section 6.2, you'll see it 6.3, but I will update the description boxes for that. Okay, so we're just carrying on with more of what we did in 6.1, so I'm only going to do 3 examples. Like I said, I started this and forgot to mention the video thing that I wanted to mention at the beginning. So 2x to the 1/3 times all of this for number 5. We just multiply 2x to the 1/3 times each one of these. So you can break it down. 2x to the 1/3, you're going to see it 3 times. You're multiplying it by this one, and then this one, and then this one. So I have 2 times 3. I'll put it over here as 6. And then x, what I'm going to do is I'm going to take 1/3 plus 8/3. This is not raised to a power. This is x to the 1/3 times x to the 8/3. So we add. Luckily, they're both thirds, so we have 9/3. I'm going to do it down here. I'm going to skip the step of simplifying. 9/3 is 3. So I have 6x cubed minus, well, here I have, well, I should say positive 2 times negative 4. That's where I get my negative. 2 times 4 is 8. And I have 1/3 plus 5/3. This is a negative 4. I've multiplied and I have a negative. I'm still adding my exponents. So 6/3 is x squared. Then I have a positive and a positive, so I'm adding. I have 2 times 5 is 10, and I have x to the 1/3 plus 2/3 is x to the 3/3, so 1x. So number 5 is number 5 is 6x cubed minus 8x squared plus 10x. And now down here, I skipped ahead quite a ways. I had to do 1 through 25. So I did 1 from that chunk. They're all basically the same. Then I'm going to pick one of these where we're squaring. Remember, all you're doing is now you're saying a to the 1/2 minus b to the 1/2 times a to the 1/2 minus b to the 1/2. So you're multiplying this by both of them and this by both of them. So I'm going to skip steps again. I'm going to take a to the 1/2 times a to the 1/2. Because a is my same base, my same variable, I don't say a times a is a squared and then half plus half. I literally have a to the half and a to the half. I'm going to add them together. Then I'm going to take, and I don't know the best way to show this. I'm going to skip this step too. Instead of putting a positive a and a negative b together, I have a positive a times a negative b. I know it's going to be a negative. And I'm going to have a to the 1/2, b to the 1/2. Then I start here. I have a negative b times a positive a, so I'm going to have another negative. And it's a perfect square, so you know there should be a -2 of something in the middle. So again, I have a to the 1/2, b to the 1/2. This is what some students might slip up a bit here. Now the next one is a negative times a negative is a positive. I have a b and a b, so my focus is my exponents. So what I have is a to the 1/2 plus 1/2, that's 1, so just a, minus 2 of these. 2 of those, and the book should leave it. Let me make sure. Yeah, the book's going to leave everything as is in fraction form in this order. And then plus b to the 1/2 plus 1/2. 1/2 and a half is a 1. So that's my answer. You're going to have 2 if something's squared, and I believe there's 1, 2, 3, 4. There's 4 that are perfect squares. And then you'll notice I gave you one where they're opposites. There's a plus and a minus. Okay, and then 42, I assigned 41, so you do one division problem. I'll do number 42. I'm going to write this out a little more lengthy, just so you can get a feel for how to do these. Whoops, not a 20, it's 30. I don't want to be that far off. So what happens when you're doing these division problems is, this is the denominator. That means it's the LCD. That means you're dividing it into both of them. So you can separate it if you want. And say 5 goes into 25 5 times. Then what I end up with is x to the 1/4 minus 1/4. We're dividing, so you talk differences. With fractions, you're going to need an LCD. In this case, you have the LCD. So you're literally just taking x to the 1/4 minus x to the 1/4. Technically, this is where our zero rule comes into play. Any number raised to 0 is 1. So that's just 5. X raised to the 0 is 1. What happens is those cancel out. You know that. It's the same exponent. It becomes 1. The exponent rule proves it. 1/4 minus 1/4, 0. X to the 0. Anything raised to 0 is 1. So that's where we prove that rule, that those go away. Then I'm adding 30 divided by 5, which is 6. And I have x to the 3/4 minus 1/4. So I have 6x to the 2/4, which is 6x to the 1/2. And let's see if they leave it. Yeah, they leave it. You can write 6x to the 1, well, you wouldn't in this 142, but when you're doing a problem like this, you can write 6x to the 1/2 plus 5 if you want to. The book just leaves it here. You never really know with the textbook. Sometimes they want that variable first. Sometimes they just leave it as is because they want you to know the process. So that's section 6.2. They're all the same. Multiply, 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 fraction, 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 add them together until number 41. I just gave you one division problem. So hopefully you enjoy that. I think it's a pretty good section.